So, moving right along, I don't know where that EHOR thing comes from with the whistle, but Simple Network Management Protocol, SNMP, remember it's technically UDP ports 161 and 162. However, 161 does go both ways. TCP and UDP depends on what you're using it for. SNMP developed to allow administrators to manage nodes on an IP network. Enables administrators. Yeah. What? Get feedback. Let's see here. Beautiful. Anyway. Enables network administrators to monitor and manage network performance, find and solve network problems, and plan for network growth. Understand that SNMP kind of operates as such. You configure it on your devices, community, etc. You got 3 versions of SNMP, V1, V2, which is actually V2C, and then SNMP V3. SNMP V1 and V2 are typically used in read-only mode because, security is weak. SNMP V3 is the way to go because it includes authentication and encryption, which makes SNMP much safer. SNMP operates 2 ways. You can either, from a network management system, poll, query, reset interfaces, things like that, or I should say, your network management system can just receive unsolicited traps. That means you configure SNMP when a certain level event takes place. The device then logs the error message along with the timestamp, considering you used SNMP properly, into the network management station unsolicited. Okay? So that means that the SNMP manager station receives traps from devices whenever there's a fault condition on the network. All right. And you can then, reset an interface, gather statistics, counters, all that good stuff. A lot of stuff you can do with SNMP. Anyway, an application layer protocol that provides a message format for communications between managers and agents. The SNMP system, Simple Network Management Protocol system, consists of 3 elements: an SNMP manager, the managed nodes themselves, which are SNMP agents, and then the management information base in each device. Now, do understand that MIBs, occasionally, there are standardized MIBs. That means objects and things that you can do in devices with SNMP. And then many vendors have vendor proprietary MIBs that you would then install in your network management station running the SNMP app so that you could gather and do other things. SNMP defines how management information is exchanged between network management applications and management agents. The SNMP manager polls the agents and queries the management information base for Simple Network Management Protocol agents on UDP port 161. SNMP agents send any SNMP traps to the SNMP manager on UDP port 162. The SNMP manager, look at the diagram, part of a network management system, NMS. The SNMP manager can collect information from an SNMP agent using the GET action. You got a couple of different things you can do: get next, get bulk, okay? And can change configurations on an agent by using the set action, okay? Set condition, etc. SNMP agents can forward information directly to a network manager using traps. Traps are typically unsolicited. That means the SNMP manager doesn't know it's coming because it's an alert that something happened in the network. The SNMP agent and management information base reside on SNMP client devices. MIBs store data about the device and operational statistics meant to be available to authenticated remote users. The SNMP agent is responsible for providing access to the local management information base. SNMP agents that reside on managed devices collect and store info about the device, its daily and its operation locally in the management information base. SNMP manager then uses the SNMP agent to access the information in the MIB. Two primary SNMP manager requests, get and set. In addition to configuration, set can cause an action to occur, like restarting a router, shutting an interface down, bringing it back up, okay? Bouncing a protocol like OSPF to clear it. Get request retrieves a value from a specific variable. Get next request retrieves a value from a variable within a table. The SNMP manager doesn't need to know the exact variable name because the device will do a sequential search to find the needed variable within the table. Get bulk requests to retrieve large blocks of data, such as multiple rows in a table that would otherwise require transmission of many small blocks of data. This only works with SNMP v2 or later. Get response replies to a get request, get next request, and set request sent by a network management station. This is a computer on the network. You're running an SNMP management application. You probably have a syslog server installed on it also, and you are the general location where all kinds of error messages are targeted to. Okay? Syslog is typically used to correlate SNMP events, along with the fact that syslog logs slightly different information from SNMP. So you can correlate it to get to the heart of the problem on the network. And then you have a set request to store a value in a specific variable. The SNMP agent responds to SNMP manager requests as follows. Get an MIB variable, management information-based variable. The SNMP agent performs the function in response to a GET request PDU, protocol data unit, from the network manager. The agent retrieves the value of the requested MIB variable, responds to the network manager with that value. Set an MIB variable. The SNMP agent performs this function in response to a set request PDU from the network manager. The SNMP agent changes the value of the MIB variable to the value specified by the network manager. An SNMP agent reply to a set request includes the new setting on the device. Okay, so if you want to check the MIB variable to find out if G000 is up and up, you can send the SNMP get from the network management station. The device will take the appropriate action and return the appropriate value as a result of what you requested. Do note, your request may come back with a negative value. If you tell an interface to go back up when it was down, well, if the condition that caused it to be down is not resolved, it's going to go back down, and the response is going to be that the interface is up, down. Traps are unsolicited messages alerting the SNMP manager to a condition or event on the network. Trap-directed notifications reduce network and agent resources by eliminating the need for some of the SNMP polling requests. Figure illustrates the use of an SNMP trap to alert network administrator that int G000 has failed. The NMS software can send the network administrator a text message, pop-up window on the network management software, or turn the router icon red in the network management station graphical user interface to indicate an error condition on the link. Okay. SNMP v1, legacy standard. Defined in RFC, request for comments 1157, uses a simple community string-based authentication method, should not be used due to the security risks. SNMP v2 came out and almost immediately became SNMP v2c. Defined in RFCs 1901 to 1908, uses a simple community string-based authentication method, which means it's not secure. Provides for bulk retrieval options as well as more detailed error messages. SNMP v3, which is what you should use, defined in RFCs 3410 through 3415, uses username authentication, provides data protection using HMAC MD5, HMAC SHA, and encryption using DES triple DES or advanced encryption standard. SNMP v1 and v2 use community strings that control access to the management information-based community strings of plain text passwords. Community strings authenticate access to MIB objects. There are two types, read-only, read-write. Read-only provides access to the MIB variables, but does not allow changes to the variables, only read options. Because security is minimal in version 2C, typically used in read-only mode. Read-write. This type provides read and write access to all objects in the MIB. That means you can shut interfaces down, bring them up, turn down routing protocols, all kinds of good stuff. To view or set MIB variables, the user has to specify the appropriate community string for read or write access. The MIB, Management Information Base, organizes variables hierarchically. Formally, the MIB defines each variable as an object identifier, OID. OIDs uniquely identify managed objects. Now, do realize in some cases, you have proprietary OIDs that you would download and install into your management information base on your network management station. The MIB organizes OIDs based on RFC standards into a hierarchy of OIDs, usually shown as a tree. The MIB tree for any given device includes some branches with variables common to many networking devices and some branches with variables specific to that device or vendor. RFCs define some common public variables. Most devices implement the MIB variables. In addition, networking equipment vendors like Cisco can define their own private branches of the tree to accommodate new variables specific to their devices. So this is where I tell you, occasionally you got to get these OIDs from the vendor. Install them into your management information base on your network management station so you can control these OIDs that are proprietary. The figure shows portions of the MIB structure defined by Cisco. Note how OID, object identifier, can be described in words or numbers to help locate a particular variable in the tree. OIDs belonging to Cisco are numbered as follows: .iso 1 org, 3 DoD, Internet, 6 1 private, 4 enterprises, 1 Cisco, 9. So note that these are structured like you see here, 1.3.6.1.4.1.9. You get the idea. So the first is ISO, okay? Then you have Organization, Department of Defense, Internet, Private Enterprises, and Cisco is the last at 9, okay? An idea of what they look like, the address of the device, and then the OID number, and then inevitably the value obtained from that specific OID. SNMP can be used to observe CPU utilization over a period of time by polling devices. CPU statistics can then be compiled on the network management station and graph. Creates a baseline for the network administrator to operate from. They know when the device is running low or high utilization. Data is retrieved via the SNMP GET utility issued on the network management station to the agent running in the device. Using the SNMP GET utility, you can manually retrieve real-time data or have the network management station run a report. The report would give you a period of time. You could use the data to get the average. Okay, so you see how all of that goes. And every part of that string from the 1322 timestamp to the who the network manager is, or email address, etc. All of this can be specified. You have SNMP get version 2C. C, the community string is community. IP address of the device, the OID identifier, and then everything leading to an integer value of 11, not 11. The SNMP object navigator, SNMP get utility, gives some insight into the basic mechanics of how SNMP works. However, working with long MIB variable names like, we had before, .9, which was Cisco, .2.1.58.0, can be problematic for an average user. More commonly, network operations staff uses a network management product with an easy-to-use GUI. Makes the entire MIB data variable naming transparent to the user because it's more textual. The SNMP Navigator on Cisco.com allows the network administrator to research details about all different OIDs that you see there, okay? So you see there, the actual object is why reload? There's your string to get to that. The type is display string, it's read only, the status is mandatory. The MIB that's the management information base being used, okay? And the variable contains a printable octet string that contains the reason why the system was last restarted, okay? Give you a rough idea how that goes. Syslog, you know syslog, you've done it already, I told you. SNMP and syslog, you'll probably have both running on a network management station. Why? So you can correlate events between the two. Syslog uses UDP port 514 to send event notification. Now, this is by default, of course. It's changeable in syslog easily, just like 21 is changeable in FTP. And 80 in HTTP, you could change that to 8080. There are a couple of port numbers you can change, but these are the default, well-known port numbers where you can expect to find these services running, okay? Syslog, UDP port 514, used to send event notification messages across IP networks to event message collectors, as shown in the figure. Syslog server, that's probably a network management station, also running SNMP. The syslog logging service provides three primary functions as follows: the ability to gather logging information for monitoring and troubleshooting, the ability to select the type of logging information that's captured, and the ability to specify the destinations of captured syslog messages. Now, you would configure your routers and switches to send syslog messages to a network management station so that they can be archived for one, analyzed for two, and used in the investigation process when you have issues. Syslog protocol starts by sending system messages and debug output to a local logging process. That's the buffer in the device, okay? Syslog config may send the messages across the network to an external syslog server where they can be retrieved without needing to access the actual device, okay? So you can look at it on a syslog server. Now, the difference between looking at it live in the device and looking at it in the syslog server, obviously the server has more rich features for filtering the output. So you can look at only what you want to look at without having to know a long command line to see only what you want to see, okay? Anyway, alternatively, syslog messages can be sent to the internal buffer. Messages sent to the internal buffer are only viewable through the CLI of the device, and they are first in, first out. As newer messages come in, older messages drop out of the logging buffer. It's FIFO, okay? Network administrator may specify only certain types of system messages be sent to various destinations. Popular destinations for syslog messages are the logging buffer. This is locally inside the device in RAM, okay? So when the device finally does crash, everything in the logging buffer is gone. At best, you can hope for a dump file, okay? Console line, everything, debug and down to 0 is sent to the console line. terminal line does not get all syslog messages by default, and a syslog server will capture, or not capture, but actually the device will send whatever logging trap level you specify. Do realize that packet tracer, it only does debug, okay? If you're using GNS3 or something, everything works the way it's supposed to. So if you say logging trap level 4, then all you get is 43210. Now realize one key thing. When you get down to 0, the device is pretty much done. You might not be logging anything anywhere at that point. You're at the crap out point where the device is about to reset or hang, okay? Just letting you know. Anyway, each of the levels are different. You got alerts, warning, informational, critical, all that good stuff. But you definitely don't want to send anything less than 4, all right? So typically we go with 4, and in many instances, level 5 notifications. Cisco devices produce syslog messages as a result of network events. Every syslog message contains a severity level and a facility, okay? So what it referred to, okay? Smaller numerical levels are the more critical syslog alarms. The debug is 7, okay? That's the highest, all right? Not critical, it's just, the device generating information based on what's going on in it. Now, do note, realistically, you shouldn't see anything, the typical messages like a routing protocol came up, an interface went up or down, all right? You would see those on the console instantly. However, when you log them to a syslog server, you should log trap level 4, which is a warning. Okay, that means an interface went up or down. 3, interface up or down, an error condition. All right. Memory issues, processing issues, or critical conditions. Immediate action needed. You're about to go down, and look, level 0, you're done. The severity level of the messages can be set to control where each type of message is displayed, for example, the console or other destinations. Complete list of syslog levels is shown in the table. So emergency is 0. System is unusable. Alert, level 1. Immediate action, critical, 2. Critical condition. Error, 3. An error condition. Warning, level 4. Warning condition. Notification is 5. It's a normal but significant condition, okay? Informational is level 6. That's just an informational message. No sense in logging those. Debug, level 7 is a debug message, okay? Okie dokie. Then there are additional things that go into that, all right? In addition to specifying the severity, syslog message also contain information on the facility. Syslog facilities are service identifiers like %CDP, 3%, something like that identify and categorize system state data for error and event message reporting. Logging facility options that are available are specific to the network device. Some common syslog message facilities reported on iOS routers are IP, the OSPF protocol, like adjacency changes, things like that. Sys for the operating system, IPsec when you got tunnels going up or down or something, and IF for interface, okay? Kind of what it looks like. By default, format of syslog messages on Cisco iOS software is as shown. Percent, the facility, CDP, whatever, link, whatever. The severity level, 3, 4, and a mnemonic, which is up, down. Okay, like up or down, adjacency change. And then you have the description there after the colon, which is interface, port channel 1, change state to up. Okay, is the facility. Here the facility is linked, the severity level is 3 with a mnemonic of up or down. By default, timestamps, you got to remember to set those timestamps, because if you're going to send error conditions to a syslog server, or an SNMP, network management station, they should have the appropriate date and time. Remember, anything related to security, you can't prosecute if you don't have the right time. It's a simple fact. A judge will look at it, laugh, and say, I can't help you. You can't rob the bank 10 minutes before you get to the damn bank. By default, log messages, not time-stamped. Log messages should be time-stamped so that when they're sent to another destination like a syslog server, an SNMP management station as an unsolicited trap, there's a record of when the message was generated. You can use the command service timestamps, log date time to force logged events to display the date and time. Okay. Now realize you're using NTP on the network also, so everything should have the correct date and time. Router and switch file maintenance. The iOS file system, if you were to go to a router privilege exec or a switch privilege exec mode and type show file system, you would see all the different file systems in the device, okay? You have opaque, disk, network, NVRAM, get it? The flags can be read, write, read only, okay, write only, and the prefixes. You got system, temp sys, boot, flash, flash, USB, web UI, null, tar, TFTP. Remember these devices, you have HTTP, FTP, RCP, SCP, SFTP, secure FTP, HTTPS. Why? Because these devices run all of these services. Now, most of these services are disabled by default. Some you have to enable, okay? But they run all of these services, which means they need the appropriate file systems to operate those services, just like a server needs its file systems. The iOS file system, IFS, allows an administrator to navigate different directories, lists the files in a directory. The administrator can also create subdirectories in flash memory or on a disk. Okay, there are really no disks in these devices, so it's in flash memory. The directories available depend on the device. Now, when I say disk, we're talking about USB, if it's that. But, rarely, if ever, do you leave a USB stick in there permanently. The example shows the output of the show file systems command, lists all the available file systems on a 4221 router. Okay, now do realize the asterisk indicates where you booted from. The default file system, the pound sign indicates a bootable disk. Both of these are assigned to the flash file system by default. If you were to type dir, you would get the directory of whatever folder you want if you include the folder. Look, this operates much like a command line, command prompt in a DOS system, a DOS dialog box, or a Linux prompt. Because Flash is the default file system, the dir command lists the contents of Flash. Of specific interest is the last listing. This is the name of the current iOS file image running in RAM. So you see down there, you got Universal ISR 4200-Universal K9, IAS 16.09.4 SPA bin. And it tells you how much you have free in Flash. To view the contents of NVRAM, you have to change the current default file system using the CD. Change directory command as shown in the example. Now look, you can just type dir nvram : it'll do that. Present working directory command is pwd. You type that, it tells you where you're at. Command verifies you're viewing the NVRAM directory. Finally, the dir command lists the contents of NVRAM, although there are several configuration files listed. Of interest is the startup config file. Okay, so right there, that startup config is what you're booting to. In a switch, take a look, it's the same stuff, okay? Show file systems also in a catalyst switch, and you'll get the same thing. In fact, almost exactly the same thing, other than switch specific directories, okay? Using a text file to back up a configuration. Config files can be saved to a text file by using term. All right, you can start the log option. You should know this already. And then you could type show running config or show startup config at privilege exec. That will display it when you return to the prompt. You can just close the app or shut down the log facility and then view the file. Generally, I drop them on the desktop until I move them off to somewhere else. But do realize sometimes in these applications, you have to clean up the file because it's not like you can just paste that directly back in, okay? Depending on how you save the file, it may come up with a couple of garbage characters, and it may have stuff that you don't need, like building configuration. That's not a command. That's part of the output of the show run command. So there are a couple of things you have to clean out. Typically, you go down to the services, and that's where you start leaving stuff behind. But you always have to scroll through the file to look for garbage characters like little square boxes and dashes, etc., because that stuff's not supposed to be there. But again, it depends on the terminal app. Same thing, when you copy it to a TFTP server, it goes through as a string. If you copy it back and open it up in a text editor, it might look a little funny because it'll be word wrapped everywhere, okay? Using a text file to restore a config. Config can be copied from a file, then directly pasted to a device. The file will require editing to ensure that encrypted passwords are in plain text and that non-command text, such as the -- more -- and various iOS messages are removed. Otherwise, they will generate errors and cause the entire config to go off track, okay? In addition, you may want to add, enable, and configure terminal to the beginning of the file or enter global config mode before pasting the config. Instead of copying and pasting, config can be restored from a text file using term. When you use term on the file menu, click Send File. Locate the file to be copied into the device, click Open. Term will paste the file into the device. But do realize, like I said before, you got to clean these files up. Also realize that when you paste a config file in like that, the default behavior of a layer 3 interface is administratively shut down. So if what you paste into the device does not have no shut on the necessary layer 3 interfaces, they're administratively down by default, okay? Realize that. So you must put the no shut on layer 3 interfaces. Remember, on switches, layer 2 interfaces are administratively up by default. But VLAN interfaces, port channel interfaces, they're administratively down by default. Well, the port channel isn't, but if it's a layer 3 port channel, it is. All right? You have layer 2 and layer 3 port channels. You've already configured ether channels, which would be layer 2 port channels because they're truncated. Now, if you were to go to that port channel and say no switch port and put an IP address, it will shut down. And that interface must be turned up manually. So keep that in mind. Layer 3 interfaces have to be turned up manually. Layer 2 interfaces are always administratively up by default. Okay? Using TFTP to back up and restore a config. Okay, now do note that the TFTP server, you must be able to ping it from whatever device. They tell you that you should ensure there's enough space on that server to store the file. Look, if there isn't enough space on a server to store a couple of kilobyte text file, or a couple of byte actually, or even a 64 megabyte operating system, then I think you need a new server administrator because there should be gigs free always. Anyway, enter the copy running config TFTP command. Then it will prompt you for the IP address of the host where you want to store the file. You can enter the name. It will take the default name running-config. Okay. Press enter to confirm each choice. Now, when you press enter, you should see exclamation points, okay. indicating that the file transferred over, okay? Use the steps to restore the running config from a TFTP server, copy TFTP running config, press enter. It'll ask you the name of the remote host, that's the server. It'll ask you the name of the file you want to pull. Give it the name of the file, press enter to confirm. As long as you see exclamation points and your prompt change to what it's supposed to be, and the OK at the bottom, you're good to go. USB ports on a Cisco router. Once upon a time, they did have USB ports, but they didn't do nothing. I don't know, it took them a minute to figure out how to keep them secure. Even at that, they still only read FAT16. They don't do FAT32. They don't do NFS, HFS, or any of the other file systems. It's FAT16 and FAT16 only. Yes, it's wasteful. Who carries a FAT16 formatted flash drive? Nobody. Okay, but that's all that works on the Cisco USB port. Universal Serial Bus USB storage feature enables certain models of Cisco routers to support USB flash drives. USB flash feature provides an optional secondary storage capability and an additional boot device if you want to leave it in there. USB ports on a Cisco 4321 router are shown in the feature figure down below. You've seen this. You've already worked on 4321s. It's what we had on site. Once you plug it in and the device is enabled, you can type dir USB 0 : to see the contents. You can issue the show file systems command to verify the USB drive is there. Confirm its name. For this example, it's USB flash 0: You can use copy run USB flash : / to copy the config file to the USB drive. Well, be sure the name of the flash drive, as indicated in the file system. The / is optional, but indicates the root of the USB flash drive. You can also drop stuff into folders if you say / temp dir / and then the name of the file when it prompts you. Okay. If a file already exists of the same name, it'll ask you if you want to overwrite it. Do note when you're storing config files, they should pretty much be dated and everything, and you should have a file of the current date that you're saving it, because yesterday's file might have been different. Use the dir command to see the file on the USB drive. Use the more command to see the contents. Okay. These are Unix-based operating systems on Cisco devices. So if you want to look inside a file, just tell it more in the file name. Okay. To restore configs with a USB flash drive, it's necessary to edit USB R1 config with the text editor in this case. Assuming the file name is R1-config, use the command copy USB flash 0: / R1-config to restore a running config. Do note if you edit it in Notepad and you give it an extension of .txt, you're going to have to provide that to transfer it. Password recovery process for routers and switches is different. And it's even different still on the big chassis units. All right. So on your basic iOS router, the ISRs like that, in TerraTerm and PuTTY, hit Alt-B after powering off the device. Count 10, power it back up. Within 60 seconds, repeatedly press Alt, hold the Alt key, and press B. Release Alt, B. Now, realistically, you should only have to do it one time. Have fun with that. Anyway, for encrypted passwords, such as the enable secret password, passwords have to be replaced after recovery. Depending on the device, the detailed procedure for password recovery varies. All right, all password recovery procedures follow the same basic principle. You power down, you power up, enter ROM monitor on routers. That's, like I said, by using Alt-B in Terraterm or PuTTY. Technically, you only have to hit Alt-B once, but you almost never catch it at the right point. So I just Alt-B. Wait a couple of seconds, Alt-B. Get it? In a catalyst switch, you pull the plug since there is no power switch. Count to 10, put the plug back in, and immediately press and hold the mode button in the lower left-hand corner of the switch. Now, in a router, when it comes back up and it's broken the boot sequence, you'll be presented with a ROMMON right shift character prompt. It'll look like a user exec with ROMMON in front of it in lowercase. Remember, ROM is case sensitive, doesn't matter, router or switch, it's case sensitive. Commands are entered in lowercase, okay? In this case, you could change the configuration register once you're at a ROM monitor prompt. Now, there are two ways of doing that, all right? In this case, since it's password recovery, you would just change the configuration register to 0x2142. So you would type CONFREG in lowercase, press the space bar, and then type 0x2142 and press enter. The device will tell you you have to reset for your changes to take effect. Now, the command to reload the router in ROM monitor is in fact reset, not reload, okay? Another way of doing it is you can type CONFREG with no register parameter. When you do that, it'll enter a menu-driven mode for you to set everything. Baud rate, whether you want to load the startup config, all kinds of good stuff. You should look at it once, but I'd be careful about modifying it that way. It's a pain in the ass. At any rate, after you change the configuration register and you type reset, the device is going to reboot. When the device reboots, you'll arrive at a user exec prompt. Type enable, and since the startup config, the 214, the 4 in that 16-bit hex value indicates do not load the startup config. The normal configuration register to boot normally and load the startup config is 2102. So by changing the 0 to a 4, you told the device don't load the startup config. If you don't load the startup config, there are no passwords. That means you'll be brought to a user exec prompt. Type enable to get the privilege exec. You won't be prompted for a password. As soon as you get the privilege exec, you type copy, start, run. That will bring back the original config file that was not loaded. But since you're already in privilege exec mode, you are past the point of needing the password. As soon as the startup config becomes the running config, you'll see the router prompt changes to the name of the device as per the startup config. Immediately go to global config, because do note, if you sit there for 10 minutes, you're going to get logged out and you're going to have to reboot the device again. You won't have to change the register again, but you will have to restart it because you won't have the password to get in. Get it? So once you're in privilege exec and you've typed copy start run, once the startup config is initialized on the device, immediately go to global config and reset all passwords. Once you're done resetting all the passwords, the last thing you're going to do is type configure-register, not CONFREG. This is configure-register 0x2102. You will then hit Control-Z or type exit to get back to privilege exec mode. You will type show version, okay? The last line of the show version output indicates what the current configuration register is. And in parentheses right next to it, it indicates what it will be when the device reboots. As long as it says the configuration register is currently 0x2142, and in parentheses it says will be 0x2102, you're golden. At that point, just type copy run start and log out of the device. You do not have to reboot it. Okay. Now in the switch, like I said, you pull the plug, put the plug back in. When the device, as soon as you put the plug back in, you press and hold the mode button. Cisco says 10 seconds, or you can watch the idiot lights in the front, knock yourself out. Me personally, I'll just stand there for like 15 to 20 seconds. This way I know when I let go, I'm good to go and I don't have to get it back up off my butt again. So anyway, I'll hold the mode button for about 20 seconds, a little less, 15 to 20. 10 seconds might not cut it. Everybody's interpretation of 10 seconds is different. Okay. So 15, 20 seconds and you're good. They say you can watch for the system light and all of that, the lights above port 1 and 2 to determine if you're good. Yeah, okay, knock yourself out. I'll hold it for 20 seconds. I know I'm good. Anyway, when I release it and I go back to the terminal putty, I will see a switch : prompt. That indicates to me that that device is in ROM mode for the switch. Immediately you type flash, FLASH, underscore INIT, flash underscore init, all one word, all lowercase, because again, it's case sensitive. When you type flash underscore init and you press enter, it'll tell you it's initializing the flash file system. Once it passes all the checks and it says okay, press enter. You'll still be a switch : prompt, but at this point, you'll be able to say, rename flash : / CONFIG.TEXT space, whatever you want to rename it to. So let's say it's rename flash : / CONFIG.TEXT space flash : / CONFIG period OLD, meaning old. Get it? Then press enter, then type reset and let the device reboot. Because you renamed the config.text, the device has no startup config. Get it? Now you go to user exec, get the privilege exec, and then you type copy flash : / config.old space run. As soon as it loads up on the device, you type config T, reset all your passwords, jump back to privilege exec, type copy run start, you're done. Okay. You didn't have to change any configuration registers. All you did was rename the file. But after you set your passwords, when it rebooted, you said copy run start. So now it has a valid config.text file. And you're good to go. Log out of the device. It's done. Okay, so this is what it looks like. Enter ROM-mon mode with console access. User can access ROM-mon mode using the break sequence during the boot up process or removing the external flash memory when the device is powered off. When it's successful, you'll see ROM-mon ROM-mon 1 / prompt as shown in the example. Okay, every command you enter, the ROM-mon value bumps. Change the config reg. CONFREG 0x2142. Now I'm going to tell you right now, okay? When you enter these configuration register values, you must be very careful because there are some values that you cannot recover from once that device power cycles. So be very careful that you entered the correct value. There are all different values that you can enter that allow you to change the baud rate and all kinds of other things. The two that we work with are 0x2102. That's a normal boot, load the startup config in the iOS but in the default manner. And then 2142, 0x2142 is so that it does not load the startup config so that you can perform password recovery. All right, so after setting the config reg to 0x2142, type reset at the prompt to restart the device, enter the break sequence when the device is rebooting and decompressing the iOS. Now, once you set the configuration register to 2142, you're not going to do the control break sequence again. 2142 is what we want it to boot with. Get it? You have to do the break sequence when you don't have the password to set the register to 0x2142. Once it's at 2142, type reset, just let the device reload. You will not be prompted for passwords because the startup config will not load. Okay, once you're up and running, you get to user exec, go to privilege exec. You won't need the password. Type copy start run. Once it goes up in the device name, note it changed from router to R1. Go to global config, reset all necessary passwords. Change the register to config register 0x2102. And then copy run start. Okay, there you go. Packet tracer. Got a half hour to work with this one, so 2:35. Okay. Any questions?
Nope.
No questions? You good? I'll take the roar of the crowd to mean yes. I think you're the only one here today. Wow, man. You and Kevin.
Pretty much.
Damn. Yeah. Okay. Yeah. Now everybody ran back to the computer. What are you watching on TV? Anyway, work this one, the packet tracer backup config files. Okay? Half hour, 2:35. Then you got another lab after this. Everybody done?
Yep. Well, I am.
How many people are done? Text, holler, one or the other. Let us know you're still around. Everybody done? That must have been easy. I must be given too much time to get these done. Okay, you got another lab. Okay, let's see. You know what? I think there's which one is it? Let me see something here.
Vape break.
Vape break. Yeah, all right, take a vape break till 2:48. How's that sound while I find the next one? I believe there's another one.
All right.
Okay. Oh, let me find it. Take 15. Ready to start rolling?
Mm-hmm.
And you guys got some really damn bad cabin fever. You guys ain't even speaking a language anymore.
They're making noises.
Right? That's some sad stuff. I don't know what to say to that one.
I mean, at least they're communicating. They haven't gone completely,
Right?
crazy yet.
Not doing it by clicks and pops.
Not yet, but a little while more and it's probably going to be there.
Yeah, right? Anyway, moving along. This next one here, don't worry about it. You should definitely research password recovery procedures. It's like I told you, for the higher end equipment, it's a little bit different. Like if you have a chassis unit, a lot of times on that equipment, you got to pop a specific blade in order to do password recovery. In other words, if that particular blade location, like blade 3, is populated, you can't do password recovery. Okay? Some other models simply power it off, power it on, just keep pressing enter as it boots. That's the way it used to be on the older catalyst switches, but not anymore. Nowadays, it's a specific blade you have to pop loose to do password recovery. And then on RSMs, it's like password recovery as usual from within the switch interface. iOS image management. Do note that you're always going to have to revise operating systems upward or something for features, various things, updates, etc., security patches. The TFTP servers as a backup location. All right. Now, if you have the USB slot on your device, yes, you can use that as a backup location, but a lot of times we use TFTP servers on the network for a lot of things. As the network grows, the iOS software images and config files can be stored on a centralized TFTP server accessible in your LAN. Now, do understand, TFTP across the internet is not reliable at all because it's UDP. Across the internet, it's not reliable. Why? Because the internet is more packet switched than your network is. Most of your network is switched, not necessarily routed, packet switched. All right. But on the internet, everything is purely packet switched. So packets arrive out of order if they get there at all. And, realistically, you can copy files to a TFTP server in the internet all day and have them crap out most times. However, in your LAN, where communications is for the most part serialized, TFTP should be damn near 100% reliable, okay? As the network grows, the iOS software images and config files can be stored on a central TFTP server. Helps to control the number of iOS images and revisions to those iOS images, as well as config files that have to be maintained on a device-by-device, operating system by operating system. In other words, platform model type scenario. Production networks usually span wide areas, contain multiple routers. For any network, it's good practice to keep a backup copy of the iOS software image in case the system image on the router becomes corrupted or accidentally erased. Do note, this also means that you need a centralized repository for your licenses for various operating systems and a centralized repository for your configuration files for those devices. Widely distributed routers need a source or backup location for iOS software images. Using a network TFTP server allows image and configuration uploads and downloads over the network. The network TFTP server can be another router, workstation, or a host system running server software. Now, do note, if you look when we typed show file systems, you saw that it had a TFTP file system. That's because every single router can act as a TFTP server. So too can switches. To maintain network operations with minimum downtime, it's necessary to have procedures in place for backing up iOS images. Allows the network administrator to quickly copy an image back to a router in case of a corrupted or erased image. You would use the following steps. First, ping the TFTP server, make sure you can reach it. If you get a response, you can get there. Verify the image size and flash. In other words, verify the TFTP server has sufficient disk space to accommodate the iOS software image. On a router, you could use show flash or whatever to determine the size of the iOS image. Copy the image to the TFTP server. Copy the image to the TFTP server using the copy source URL, destination URL. This is as simple as saying copy flash TFTP. It will prompt you for the necessary information, the address of the server, the name of the file. Now, do note that sometimes when you're copying an iOS from flash to TFTP, even though you type the file name exactly correct, it doesn't work, all right? So the easiest way is if you type show version and select only the file name all the way through the bin in the bin portion of the file, the extension, copy and paste that in, it'll work every time. After issuing the command using the specified source destination URLs, the user is prompted for the source file name, the IP address of the remote host, meaning the TFTP server, and what you want the destination file name to be on the device. Press enter, the transfer begins. If you're getting exclamation points, you're good to go. If you're not, you ain't good to go. So ping the TFTP server. Verify that you can actually reach it. Whether it's IPv4 or IPv6, it doesn't matter. Okay? Now, if you want to copy from the server back to the router, copy TFTP flash. You don't have to use the colon, just type copy TFTP flash. It'll ask you everything you need after that. Verify the amount of free flash. Now, this is critical. You should never have to verify how much free space is on a server. But when you're bringing an operating system into a device that has a limited amount of flash and RAM, you need to ensure, first of all, that you have enough flash to store it. Then, even though you may have enough flash to store it, do you have enough RAM to run it? Different operating systems may have different requirements in terms of how much flash and RAM they require to be stored, one, because they're stored in compressed form, and then decompressed into RAM to operate. When they're decompressed, there still has to be enough working RAM for the device to perform its functions because it needs to build various tables, etc. All right, so compare the free flash space with the new image file size. Copy the iOS image from the file from the TFTP server to the router using the copy TFTP : flash : if you want to, you don't need the colons. After issuing the command, the user is prompted for the IP address of the server, the remote host, source file name that you want to take from the device, and the destination file name, or in this case, from TFTP to flash, the source file name on the server and what you want it to read as on the destination router or switch. The boot system command, if you have multiple iOSs in flash, the device itself, in the absence of any additional commands, will always locate and load the first executable file it can find, which means if you have iOS A and iOS B, iOS A will always load first as long as it's valid. If you want to boot to iOS B, you got two choices. Either name it iOS X, name iOS A iOS X, so the first file found is iOS B, delete iOS A, or tell the system to boot to iOS B. Anyway, during startup, the bootstrap code parses the startup config file in MB-RAM for the boot system commands that specify the name and location of the iOS software image to load. Several boot system commands can be entered in sequence to provide a fault-tolerant boot plan. If there are no boot system commands in the config, the router defaults to loading the first valid iOS image in flash memory and then runs it if it's valid. Now look, you can tell the system to boot system /0:ISR 4200 -universal K9 _ IAS .16.09.04.SPA.bin. And you can also type right after that, boot system TFTP : / and the name of an iOS on that TFTP server. Okay. Anyway, to upgrade the copied iOS image after the image is saved into flash memory on the router. Configure the router to load the new image using the boot system command. Then drop back to global config, privilege exec, copy run start, reload the router, and it will boot the new image. And you got a packet tracer here. You're going to do this one. You're going to set up and use the TFTP server to upgrade the Cisco iOS image. All right, now do note, anytime you drag one of those servers out, you can click various buttons to enable whatever features you want. DNS, TFTP, HTTP, whatever. Okay, DHCP, anything. So take a little bit of time and do this lab. It's 3 o'clock. I'll give you till like 3:20. How's that sound? 20 minutes. Challenge yourself. Kick back, get it done. Can I get an okay from somebody?
Perfect.
Perfect. There you go. That's how it's done. So get busy. Knock out that lab. I think that might be the last one for this module. Let me check that little thought. Yep, it is. Oh, there's another packet tracer to configure CDP, LLDP, and NTP. So knock out this one. Take 20 minutes. Quick, fast. Get to work. What's going on? Everybody done? Going to PT, that's a lot of exclamation points. What?
He's talking about when the iOS is being, I think it's either decompressing or copied, one of the two.
The exclamation points are copies, the pounds are decompressing.
Ah, okay. So that's when it's copied.
Yeah, well, it is, because it's like 64 megs or something like that. Everybody finished?
I am.
A lot of exclamation points. You know what they mean, right? What the? Anyway, rolling along if everybody's done. You done? You done? You done? Somebody.
I am. I am.
Rolling along, just to close it out. Another packet tracer. Oh my God, I think that's 781. Yeah, you can do that one in a couple of minutes. Which one is it? 1081, I mean, 781. My God, I'm so far in the past. 1081. Look at it like this. Be happy. Because module 11 only has one packet tracer in it. But then module 12 has 1, 2, 3 packet tracers in it. So, rolling right along with this one. Cisco Discovery Protocol, Cisco proprietary Layer 2 protocol, used to gather information about Cisco devices that share the same data link. That means wire, okay? So with CDP, the only thing you can see is the neighboring device. You cannot see anything beyond that neighboring device. Even if there is another Cisco device connected beyond the next switch or router that you're connected to, you can't see it because it's bound to the layer 3, layer 2 link between devices, okay? CDP can be used as a network discovery tool to determine the information about the neighboring devices. Information gathered from CDP can help build a logical topology of a network when documentation is missing or lacking in detail. Why? Because it gives you interface values, IP addresses, all that good stuff, which can be used in conjunction with your routing protocols and next hop routers that you're forwarding to. You can actually draw a network diagram, link by link, complete with the bandwidth on the links if you know how to read this information, okay? On Cisco devices, Cisco only, CDP is enabled by default. Other vendors do not support CDP. They support 802.3 AD, which is LLDP, link layer discovery protocol. At least I think it's 802.3 AD. Somebody can fact check me. To enable CDP globally for all supported interfaces on the device. Enter the CDP run command in global config mode. To enable CDP on a specific interface, go to that interface and type CDP enable. To verify the status of CDP and display a list of neighbors, use the show CDP neighbor command in privilege exec. There are other parameters, show CDP neighbor detail, etc. Okay. Show CDP interface. Cisco devices also support the IEEE standard, okay, which is LLDP, Link Layer Discovery Protocol. Vendor neutral neighbor discovery protocol, similar to CDP. However, do note CDP will give you more information than LLDP does. You would use LLDP if you're connecting to a non-Cisco device like Juniper or something. To enable LLDP globally on a network device, enter the LLDP run command in global config mode. Do note when you configure it on an interface by interface basis, you have to configure LLDP transmit, LLDP receive. Okay. Anyway, with LLDP enabled device neighbors can be discovered using the show LLDP neighbors command. When more details about the neighbors are needed, show LLDP neighbors detail command can provide info such as the neighboring iOS version, IP address, device capability. In other words, is it a router? Is it a switch? What protocols is it running? Is it running IGMP or something like that? When the time is not synchronized between devices, it'll be impossible to determine the order of events and the cause of a given network event. You can manually configure date and time on each and every device using the clock set command, and then provide 24-hour time format, in other words, military time, the month by month name, not number, month, day, and then the year. Or you can synchronize using NTP, Network Time Protocol, which operates in stratums. Stratum 0 is the authoritative time source. Goes from stratum 0 to higher numbers. Once you hit 15, 16 is unsynchronized. So NTP only synchronizes 16 layers deep from stratum 0, the authoritative time source, to stratum 15. NTP allows you to coordinate time within milliseconds between stratums, and I'm talking only a couple of milliseconds between stratums, okay? You can configure a device in your network as an NTP server, or you can synchronize the clock of all devices in your network using an authoritative time source that can be synchronized using an atomic clock, which is not the same exact time that we use for our 24-hour clock, because atomic clocks are an exact science. Go research human time. It's not an exact science. It's always off a little bit here or there. Anyway, you can use a GPS clock or a local device configured with the date, time, etc. as your NTP server. Remember that NTP is UDP port 123. NTP networks use a hierarchical system of time sources. Each level in the system is called a stratum. Authoritative time sources, also referred to as stratum 0 devices, are high precision timekeeping devices. Stratum 1 devices directly connected to the authoritative time source. Stratum 2, such as NTP clients, synchronize their time using NTP packets from Stratum 1. Stratum 3 uses Stratum 2, Stratum 4 uses Stratum 3, and so on and so forth. Do note that NTP devices can synchronize within their stratum or to higher and lower level stratums. In other words, 2 provides time for stratum 3. 2 gets its time from stratum 1. 2 can synchronize within stratum 2 to provide a sanity check, okay, for the time. Anyway, NTP clients synchronize their time using NTP packets from stratum 1 servers. The NTP server IP address command is issued in global config mode to configure a device as an NTP server. And you can specify stratum, etc. To verify the time source is set to NTP. Show clock detail command. Show NTP associations. Show NTP status commands are used to verify that a device is synchronized with the NTP server. SNMP, Simple Network Management Protocol, UDP port 161 and 162. Do realize that 161 goes both ways, TCP and UDP. SNMP, Application Layer Protocol, provides a message format for communication between managers and agents. The SNMP system consists of 3 elements: the SNMP manager, SNMP agents, and then the management information base that agents and managers use to collect their information. In other words, the SNMP agent has a management information base built into it. The network management station has an MIB, management information base, built into it. Understand that you have your standardized, accepted MIB, and then you have proprietary OID MIBs that can be integrated into your network management station. Vendors like Cisco, Juniper, Palo Alto have proprietary MIBs. In order to get full functionality, you have to download the MIB from the vendor and integrate it into your MIB in your network management station. The manager can collect information from an SNMP agent using get action, can change configurations using the set action. There are multiple actions under each one: get next, get bulk, etc. Get the idea, right? SNMP agents can forward information directly to a network manager using traps. Traps are unsolicited. That means a network event caused the SNMP agent to send a message to the SNMP network management station that something happened. At the same time, or roughly the same time, your syslog configuration should also log an event so that you can coordinate and correlate information between SNMP and syslog to get a better idea of what happened and when it happened. SNMP v1 no longer really used. It's not used, actually. SNMP v2c is used in read-only mode because security is weak. And SNMP v3, all versions of SNMP, with SNMP v3 being the flavor of the day since it supports authentication and encryption of SNMP packets. SNMP v1 is a legacy solution. Both v1 and v2c use a community-based form of security, which is a plain text security string that can be sniffed. SNMP v3 provides both security models and security levels. The management information base organizes variables hierarchically. Object identifiers, OIDs, uniquely identify managed objects in the MIB hierarchy. Now look, those managed objects can be a routing protocol, it can be an interface, it could be counters, whatever the object identifier is within that management information base, okay? Cisco SNMP Navigator on the Cisco.com website allows the network administrator to research details about a particular object identifier. The syslog protocol uses, by default, UDP port 514 to allow network devices to send their system messages across the network to syslog servers. Remember, syslog and SNMP generally work hand in hand, so you can correlate between the two services and their reporting capabilities. Syslog logging service provides three primary functions: gather logging information for monitoring and troubleshooting, select the type of logging information captured, and specify destinations for the captured syslog messages. By default, it can be the logging buffer, which is FIFO, first in, first out. So as newer messages come into the buffer, older messages are chopped out. Okay, that's inside the router or switch. You have the console line. Console line sees 7 through 0, even though when you get to 0, it's usually a wrap. The device isn't reporting anything anymore. The terminal line, which does not by default see all 7 severity levels, okay? And a syslog server, which receives whatever level you configure as your trap level. Syslog facilities identify and categorize system state data for error and event message reporting. Common syslog message facilities reported on iOS routers are for IP, OSPF, sys for the operating system, IPsec, and interface level, as well as CDP and many, many, many others, crypto, etc. The default format of syslog messages on iOS software is %. The facility, whatever the severity level is, 7 through 0, and a mnemonic, which is a basic description of what it is, and then the actual description for what the message was. Use the command service timestamps, log date time to enforce logged events and display the date and time. Otherwise, they're not time stamped and they're virtually useless. The Cisco IFS lets the administrator navigate different directories and list the files in a directory and to create subdirectories in flash memory or on a disk. Use the show file system command to view the file systems on a Catalyst switch or a Cisco router. Config files can be saved to a text file using Teraterm. Configuration can be copied from a file from a file and then directly pasted into a device, do note you typically have to clean these up. Config files can be stored on a TFTP server or USB drive. To save the running config or the startup config to a TFTP server, use either copy runs TFTP or copy start TFTP. It'll prompt you for the remaining parameters, such as the remote device, which means the TFTP server, and then the file name as you want it to appear on that server. File system. Okay, the iOS software images and config files can be stored on a central TFTP server to control the number of iOS images and revisions to those iOS images, as well as config files that have to be maintained. Select an iOS image that meets the requirements in terms of platform features and software. Download the file from cisco.com, and then you transfer it to a TFTP server. Do note you need licenses also. They should be backed up periodically too. To upgrade the copied iOS image after the image is saved to the router's flash memory, configure the router to load the new image during boot up using the boot system / whatever the name of the file .bin is. That's it for that one. Dead. Let's